Welcome back to videos on digital logic design. This is the video that talks about finite state machine design using JK flip-flop. Now, I'm hoping at this point you have watched all the previous videos for D flip-flop, for T flip-flop. So this would be more or less another example of similar things. And I will use a different problem just to give you a different perspective. What we're going to assume in this case is it's a simple three-state device we have, and we're going to go through the steps like we have talked about them before. So we'll start with the, hang on, get my pen figured out. So let's go ahead and start with some decent colors that can be seen but not black, not to conflict with the information that's already there. So first thing we got to do step one. In step one, we have to do a system diagram, and you have to work with your users or who you're working with to figure that out. So step one, first thing is got to do a system diagram, and this system diagram we're going to call it JK example for lack of another name. And then this device, we're going to assume, just to simplify our life, we're going to assume has one input, and then we're going to assume it has two outputs, Z0 and Z1, and just to get a remembrance of what a more output is and what a milli output is, and what's the difference between those two. Okay, so we are doing step one. We got this done, and then this system diagram is completed. Now we'll do a state diagram, which basically tells us, and like we've talked about before, we have to have a legend that tell the world what it is. We're going to say here, we're going to have which state we are in. We're going to put, in this particular case, we're going to put Z0 inside the bubble. And then on the branch, we're going to have always, we put our input, we only have one input and we have one output. Now, it's really important to remember that Z1, since it's on the branch, that means Z1 depends on what value of X is, what value of input is. So therefore, that Z1 is a milli output. And Z0 doesn't care what the input is, as long as you're in this particular state, you have the same output. So let's go ahead and put this in practice and see how that all plays out. So let's say they tell us that there is a state called new, and this state new has basically, that's it, and the new maybe has an output that is 0, and then we have an output that comes, we have a changes to a different state. Let's say we call this one, I don't know, gold. Something has happened, something awesome. Gold must be awesome, so something good is happening. And then when you get here, your output is 1. The reason you go between new and old is maybe X is 0 and you got a output of 1. And if you get a input of 0, you just, input of 1, you don't change your state, you stay here and your output is 0, let's say. And then maybe in this case, when you're in gold and you happen to get a 0, our output stays as a 1. And then maybe there is another state called silver. And the state in silver, let's say, is 0 and a 1. X is 1, gets you over here. And output of this, well, let's say it's a 1. And then if you get a 1, maybe takes you to the next step, and the output is 0. Maybe if you get a 0, you stay here with the output of 0. Yeah, that's fine. So this is basically step one. You talk to your customer, you've got a state diagram, and you've got a system diagram, so you understand what the inputs and outputs are and how the inners are supposed to be working on this device. Then you say, okay, this, now you move into step 2, and step 2 says how many flip-flops are you going to use to build this thing. You look at this and you say, I have 3 states, and therefore I have to come up with a power of 2 to the number of flip-flops I need, but I got to make sure that whatever the number is, I got to come up with the smallest number of flip-flop that 2 to the power of them will be more than 2. And we know that, therefore, we need 2 flip-flops. Okay, so that's taken care of. So what do I do next? The next thing is I got to assign, I can't create a present state, next state based on new and gold and silver. I have to translate those to binary values. So what I'll do, I'll make a little table, say, okay, I have 2 flip-flop, therefore I'm going to have 2 state variables. These are called state variables, y0 and y1. Therefore, I'm going to have 0, 0, 0, 1, 1, 0, 1, 1. I'm going to have 4 possible cases. You can assign any of these numbers to any of the states. Really, there's no magic to it. I'm just going to do, so I'm just going to make an assignment. So state, when we are in state new, our variables will be 0, 0. I'm just going to go through sequence. It really doesn't matter. And then 0, 1, I'm going to gold be assigned to that, and silver be assigned to that. And this one is not used. So as a don't care. You can say not used or don't care. Whichever you say is fine, don't care. Okay. Now, in the next step is not strictly speaking, is not required, but I think it makes your life a lot easier if you redraw the state diagram with these assignments in here. So what you're going to do, you're going to come back and redo the legend. The legend now is going to be y1, y0, and we know that z0 is in here, and then x is over here, and z1 is here. Once again, all I'm doing is redrawing it, but instead of using state name, I'm going to use the state variables because that's what I need for the next step. So what I'll do is, okay, say, okay, new, state new was, we assigned it 0, 0, so it's going to be 0, 0 with the output of 0, and then this is 1 with the output of 0. And then it's going to go to this other state, which was gold. We assigned gold 0, 1, so I'll put a 0, 1 with an output of 1, and input is, that's what takes me there. And then this won't change. 0 input gives me a 1 output. And then from here, the next state I have is called silver, and silver was assigned 1, 0. So I'll say 1, 0, and that output is 0. And then in this state, if I get a 0, I'll stay here. How do I get here? I'll look up there and say you go from here to here. If the input is 1, the output is 1. And then from here, you go to 0, 0. If input is 1 and output is 0. So once again, I highly recommend you, once you've made the state assignment, redraw the state diagram so it makes a little more sense to you. So now when you're here, now we're ready for step 4. Step 4 is really kind of the meat of this whole process. That we're kind of getting ourselves ready to do step 4. So if I come and do step 4, all I have to do is say, okay, just like we do a present state, next state. That's the first thing we're doing. This is present state, next state. Present state, next state, you have a variable y1, a state variable y1 and y0. Remember to not forget your input. And then you have y1 plus and y0 plus. And don't forget that you also had, since this is JK flip-flop, you have to figure out where your J1 is, what your K1 is, and what your J0 and K0 is. Then you have to also remember to put in your Z1 and Z0. So this is more or less what the truth table used to call output. Here it got involved. We've got the excitation equation, the input to the flip-flop. We've got the next state. So this is next state. This is excitation input. not to be confused with external input, and then the output, okay? So we got a lot of work to do here. Filling this side is easy because it's gonna be 0, 0, 0, 0, 0, 1, just sequence of binary numbers, 0, 1, 2, 3, 4, 5, 6, and 7. Oops, okay, that was good. All right. Let me clean this up just a little bit. Okay. Oh, got a wrong color pen, so let's go ahead and get the right color pen. Was it blue? All right, one. Oh, well. All right, finally got the right color. Okay, so 1, 0. So now all we are doing, we're saying we are in state 0, 0. We got a 0 input. What happens? We go to state 0, 1, right? And then as long as I'm in state 0, 0, it doesn't matter what the input is, Z0, it's gonna be 0. So I'll just fill those out. Okay, and I'm gonna put a line so I don't go crazy and miss a line. So I put every 2. So, and I'm gonna go, Z0 is easy. So I'm gonna go to state 0, 1. State 0, 1, Z0 is the more, so it's 1, 1. I'm gonna go to state 1, 0, and that is 0. So let's fill this out. And these, we don't care, that state doesn't exist. So both of them are don't care there. Okay, Z1 is a little more complicated because I gotta look to see I'm in state 0, 0. I get a 0. My output of Z is 1. And then I have a 0, 0. I get a 1. I'll stay in the state 0, 0. And my output is 0. Z1 is 0. So far, so good. Okay, I'm gonna come back and do the JK later, but for now, let's walk through this thing and let's see if you can finish this out. It does take a little bit of time to do that. Now you're in state 0, 1, and you got a 0. If I'm in state 0, 1 and I get a 0, 1, 0, I'll stay in the same state, but my output is 1. And if I get a 1, I'll go to state 1, 0, and my Z is 1 also. Then if I'm in state 1, 0, and I get a 0, I'll stay in the same state. And my output is my Z1 is 0. And then if I stay in and if I'm in 1, 0 and I get a 1, I'll go to 0, 0, and my output is 0. And by the way, I don't care because that state will never happen. So all of that is don't care, which means all the J, K, J0, K0 will be don't care as well. And you don't have to do that. I'm doing it just because you just got to remember it's don't care. I'm putting the don't care just to make sure it's explicit and we don't have any questions, okay? Now, okay, so now how do we do the JK? The JK business happens by looking at here. There are 2 ways of doing it. One is just basically, and that doesn't give you the minimum. One is to use this relationship or the opposite of that relationship to do it. But I would say, let's just use this. This is a lot simpler. So J, and maybe you don't even do the table. Maybe let's do that. We don't do the table, and all we do, I'm going to go this way. I'm going to do, it says basically J1, rather than trying to write everything, J1 is basically Y1 plus, and K1 is basically Y1 plus not. That makes it a lot easier. So I don't, and in many cases, you may not even want to draw this whole thing at all and just do this, okay? And then J0, K0, same thing. This is gonna be Y0 plus, and this is gonna be Y0 plus naught. And that, I would do that. That's a little easier. It's not absolute minimum because there are some places you could have done different, some don't cares and things like that. But in this case, you know, it's fine for these assignments to make that assumption, for simplifying assumption. Okay, so now how does that help me? Well, in the job we are trying to do, we are trying to design it. In a class exercise, we're trying to get to the schematic that eventually we implement and test. And but for now, we just want to get to the schematic. In order for me to get a schematic, I have to have an equation for J1, K1, J0, K0, Z1, and Z0, which means I have to do schematic. Instead of doing the schematic for each one of the items, what I'm going to do is I'm going to do one for Y1. So we're going to do a bunch of K-maps. And Y1, Y0 is here, 0, 0, 0, 1, 1, 1, 1, 0. And here is going to be my input, 0 and 1. And I'm just going to go through Y1 plus and see it's 0, 0, 0, 1, 1, 0, don't care, okay? So if I do that, then the simplest relationship I can come up is this, and therefore Y1 plus will simply be Y1 ended with X naught, or Y0 ended with X. So if we took care of that, then you go over and do the same process for to figure out where your Y0 plus is, okay? And Y0 plus same deal. Y1, Y0, you have to keep drawing this. That's the unfortunate part of it, but it's not that complicated. So Y0, this will be 1, 0, 1, 0, 0, 0, don't care. And the simplest thing is here, ready to roll. Did I get that right? Yeah, okay. So Y plus will be Y1 naught and Y0. And I'm not going to do JK because they're just Y1 naught or Y1. So once I created these equations, I can get the J and K from them pretty easily. So the next one would be the Z, because I have to have an equation for Z1 and I have to have an equation for Z2. So I'll just go ahead and do the same thing for those guys. And that's what give me basically a 0, 0, 0, 1, 1, 1, 1, 0, 0, 1. And I say, okay, for Z1, we're doing Z1 here. So it's going to be 1, 0, 1, 1, 0, 0, don't care, which means I can do this, and this are the two that I can use, which means it's going to be Y0 for the big one, and for this one would be Y1 naught, X naught, okay? And then finally, we have the last one to do, and the last one is going to be X, Y1, Y0, 0, 1, 0, 0, 0, 1, 1, 1, 1, 0. And for that case, this is 0, 0, that's 1, 1. This is don't care, this is 0, 0. And therefore, pretty easy, Z0 simply is Y0. Once I have these expression, life, it becomes really easy. And so, I know I have two flip-flops, so I'm going to draw my two flip-flop. One flip-flop is, here's my JK, J0, K0, Q, which are, or this is really Y0, another way to say it, because we call it Y0. And then I have another flip-flop, give myself a little room. I'll do another flip-flop, and my flip-flop here is going to be J1, K1, and I'm going to have Y1. All that is really good. Okay, so the next thing I need to do is I have an input, and we're going to use our little technique of simplification. X comes in here. I'm going to run X all the way over. I'm going to invert X and run it all the way over. And then Y1, I'm going to bring Y1 up here and give myself the same option. The Y1's running all the way over, and then give myself an option for Y not. And just like we did it in the before this, Y0, as top is kind of filled up, so Y0, I'm going to have that one run. Oops, that's close enough. Oh, let me clean it up. All right, so okay. Okay, so we'll do this, and my Y0 is running this way, and I'm gonna do myself a Y not as well, so I have it across. Okay, so now all I have to do, I remember if I bring Y, whatever I came up with Y plus in here and put a not in here, that'll take care of this piece. So I only have to figure out what Y plus is, remember? Remember we said here, J is Y1 plus, okay? And if you forget it, is in the instruction for step-by-step how to do it. So all I have to do is, first thing I gotta do is I gotta figure this out. This one is gonna be Y1. So here's my Y1. And then X naught, here is my X naught. And these gotta get ANDed together. So I'll AND them together. And then Y0, where is Y0? Y0 is here, and I need X. So I'll just take the X and bring it up here. There is another AND, and I'm gonna bring them over, OR them together, and there it is. So that's my, oops, that wasn't where it should go. So it should go to, the other one. Okay. So that wasn't a good idea. Let me just erase all of this and I'll do it again. Although you probably got the idea. If you want to fast forward through this, that's fine. But I wanted to finish this just in case if somebody is new to this space and wants to see it all the way through, they have a place to go look. All right. And so that was for this guy, so I'll redo it one more time. So the first part is Y1, so here is Y1 coming down. And then X naught, this is X naught. We're gonna AND them together. And then I'm gonna bring X down, turn it up. And then we're gonna bring Y0, do an and OR them. And there we go. So that part is done. And then Y0 is a lot simpler. It's basically all it is Y1 not, oops, Y1 not, and Y0, and them together, run them through here, and that's that. And now we get the Z part. The Z is gonna be Y0. So Y0 comes up, and then go up here, and then we'll take the X naught and Y1 naught, which is this guy, and them together, and these guys get OR together, and there is my Z1. And Z0 is just simply, there it is. So I'm done with my circuitry, and you see what happened was, remember, all I did was figure out what the equation for y1 plus and y01 plus was and make those JK, and then connect the J and the K with the negative, with the inverter, and just drive y plus in there, and I'm done. And now at this point, we are done. The design is completed. But let's say somebody gives you exactly the same problem, and I'm going to use a different pen color so you can kind of see it. So we're going to use a green. So somebody comes up to you, and instead of saying JK, says use D flip-flop. Okay? So if they say D flip-flop, all the states would stay exactly the same. You still don't need to do this piece. And when you get here, this is going to be D1. This is going to be D0. Everything else will stay the same. See that? So instead of putting this, we'll just put a D in here. Okay? So all the other steps stay exactly the same. See how that works out? And then if somebody comes to you and says, okay, now I want you to use a T flip-flop, same problem, but they want you to use a different one, then what you do, you basically more or less kind of use the same trick. You say, oh, I know, if you want me to use a T flip-flop, then this stays the same, this stays the same. I still don't need this. I got over here and I've got Y plus, but I know it tells me that what comes to T has to be Y plus and or exclusive OR with Y. So what I'm going to do, then I'm going to go ahead and replace this piece. I'm going to replace it, and see, remember this signal is Y1 plus. So what I'll do is I'll take the Y1 plus, run it to my T flip-flop. Actually, no, sorry, you don't do that. Okay. Let me erase some stuff. Huh. Okay. So I'm going to take the Y plus, and I'm going to take the Y. So Y plus, Y1 plus, Y0 plus, and I'm sorry, this is Y0. Y0 plus, the equation was here, same exact way, you don't change anything. Y plus comes in here, then this is Y0 and this is T0. So you take this, run it back over here, and exclusive OR it, and run it in here. So you notice the same process, the same step 1 through 4 will exactly work for all of them until you get to the last bit. And all you're doing, you basically your D flip-flop and all that will be more or less the same, because the D flip-flop, you replace a D0, Y0, and this just you run the Y plus that you had calculated into it. And you replace, of course, you have to do that for both flip-flops. So just a quick summary of everything we've talked about. The goal of this presentation was to get you familiarized, or at least show you one more step, one more example of how to go through the 5 steps of design to get to schematic. You did your system diagram, you did your state diagram issue. You're convinced with that, figured out how many flip-flops you need based on the number of states. You assigned values to each one of the states. Highly recommended to redraw your state diagram with the assigned values in there. Then you got to do the present state, next state. Then you do a K-map for all the Y pluses, the next states, and the outputs. Then you just basically drew it. And then the last bit was that for D flip-flop, you just simply use Y1, Y0 for the D. And for a T flip-flop, your T value would be Y plus and O exclusive OR with Y. And for the JK flip-flop, you take the Y plus and run it to J, inverted, run it to K. Now notice, now you can do all of the flip-flops using the same process, and it simplifies it quite a bit. We are done with the JK flip-flop design, and a little extra how you can design all the other flip-flop using exactly the same process. And look forward to seeing you guys on the next presentation.